One special type of function is called a step function. Special type of piecewise function is called a step function, and it is the most special step function is called the greatest integer function. So the greatest integer function is y is equal to the greatest integer of x, and if you notice there's the double brackets, that's the symbol for greatest integer. The definition of greatest integer is the greatest integer that is less than or equal to that number. So, for example, the greatest integer of 2.5 is 2. 2 is less than or equal to 2.5. The greatest integer of 2.7 is also 2. The greatest integer of 2.9 is also 2. And even the greatest integer of 2.99 would still be 2, the greatest integer that is less than or equal to those numbers. But as soon as we get to the greatest integer of 3, then it jumps up to 3. So we can see that on the graph, that the greatest integer of anything in between 2 and 3 here would be 2. But then as soon as we get to 3, the greatest integer of 3 is 3. So what we have is a step function going on forever, where there's jumps at every single integer. So the next thing we're going to do is we're going to write a piecewise function for the given graph. Okay, so let's start with this first one. It looks like the open circle and the closed circle are when x equals 0. So when I write my function, f of x equals, I know that one of the inequalities is when x is less than 0 because I see that open circle with the ray going to the left. And the other part, the other piece, is going to be x is greater than or equal to 0 because I see a closed circle and going to the right. So let's start, and I also want to notice that they both have positive slopes, so I'm going to keep that in mind when I write the equation. So I want to notice that they each have a y-intercept of 0, so that makes it a little bit easier for us. And the ray or the piece that is going less than 0 has a slope of 1. So that would be also a y-intercept of 2. So that would be y equals x plus 2 if x is less than 0. And the other piece I'm noticing also has a slope of 1. I'm counting the rise over run. And it has a y-intercept of 0. So that would just be y equals x if x is greater than 0. So we can use our clues from our graph to figure out the equation of both rays and get our inequalities. So the next graph, is a step function. So let's see if we can come up with the equation for that function. So I'm going to say f of x equals, and I see it has 3 parts. And the first part is if x is greater than or equal to 0 and less than 1. And that looks like it's the line y equals 1. And the next little horizontal piece is y equals 3 if x is greater than or equal to 2 and less than 4. Sorry, the first one is not greater than or equal to 0 and less than 1. It's going to be greater than or equal to 0 and less than 2. You have to count correctly. And then the third piece is y equals 5. Way up there at y equals 5, if x is greater than or equal to, that would be 1, 2, 3, 4, 5, 6. So it'd be greater than or equal to 4 and less than 6. So we've got a little step function there. So we should be able to come up with the function if we have been given the graph. And then lastly, we're going to look at a little application. The weekday parking rates for a garage are shown. Write and graph a piecewise function for the weekday parking charges at that garage. Okay, so we've got a function, and it is just for the weekdays, $3 per half hour, and actually, we're not going to do that. We're just going to answer the question. What is the charge for parking for 1.25 hours? So for 1.25 hours, it's $3 per half hour and $18 maximum for 12 hours. So if we were in the parking garage for more than 12 hours, it would just be a flat $18. But if the x, so my first part is if x is less than 12 hours, and then $18 if x is greater than or equal to 12. So the tricky part would be to figure out this function, $3 per half hour. So it's going to be $3. It's not going to be $3 times x. It's going to be $3 times, let's see, it would be $3 per half hour. So we have to figure out how many half hours there are. How many half hours there are. There, let's see, there's two half hours in an hour, and then a half of a half hour. So we've got 2.5 half hours. So it's $3 for every half hour. So 3 times 2.5 would be, 3 times 2.5 would be, let's open up our calculator here, and we're going to get 3 times 2.5. 3 times 2.5, and that would be 7.5. So it's going to be $7.5 $7.50 to park in the garage for 1.25 hours. So this is an example of a piecewise because we've got a certain function going on if x is less than 12 hours, and then more than a different function if x is greater than 12.